Hi guys, welcome to this set of videos. What we're going to do in this set of videos is we're going to take a look at a section out here in geometry where we're going to use the properties of rectangles, rhombuses, and squares, which we've already talked about, and we're going to use those properties to prove, right? We're going to prove that a shape is a rectangle, a rhombus, or a square. So before we start taking a look at a couple of these, let's talk about exactly what it is we want to do in this set of notes. And it is simply that. We want to know how can you use the given conditions. Conditions meaning properties, right? Properties of rectangles, rhombuses, and squares. And then I will give you some additional information in the example problems. And you'll see when we start doing a couple of these problems together. But anyway, you'll use the given conditions to show that a quadrilateral is either a rectangle, a rhombus, or a square. So that's what we want to do here in this set of notes, is use those properties, rectangles, rhombuses, and squares that we've already talked about, and use them to prove that a given diagram or figure is either a rectangle, a rhombus, or a square. So how are we going to go about doing that? Well, first we're going to go ahead and investigate the conditions of those quadrilaterals, rectangle, rhombus, and a square. And then, of course, we can use those conditions to help us find unknown measures and lengths, and we've seen this over and over now here in geometry. This is really where the algebra comes in. So let's go ahead and jump right into this. We're first going to start with rectangles. Now, what you should remember about rectangles is this. Our properties for rectangles is that a rectangle is a parallelogram. It has 4 right angles. The diagonals are congruent, and they bisect each other. All right, so those are the properties of a rectangle. Now, how can we use this to prove a figure is a rectangle? Well, here's the way it's going to work. If one angle of the parallelogram is a right angle, then the parallelogram has to be a rectangle. So what you're going to do is based on the information given to you in the problem. If I tell you it's a parallelogram, that's really important. I have to tell you that first. If it's a parallelogram, and I tell you one of the angles is a right angle, well, this theorem right here says it must be a rectangle. And then we have one more. If the diagonals of the parallelogram are congruent, then the parallelogram must be a rectangle. So let me show you what this is going to look like when we actually use it in some problems. So here we go, right here. I got a great example for you. Let me make sure you can still see those properties though, right there. So there's our conditions for rectangles, right? The information we need to know in order to say for sure, yes, that figure is a rectangle. And let's just jump right into this. So here's what we've got. I want you to explain why the conditional statement, if one angle of a parallelogram is a right angle, then the parallelogram is a rectangle. Why does that statement have to be true? This one right here. If all I need, right, one angle of the parallelogram is a right angle, how do I know it has to be a rectangle? Well, let's talk about this. First, here's what we know about parallelograms. Remember our properties of parallelograms. A parallelogram has opposite angles that are congruent. So a parallelogram has congruent opposite angles. Okay, well, here's what this means for us. That means since angle E is 90 degrees, right? If this is a parallelogram, what do I know about angle G? Well, if it's a parallelogram, I know angle G and angle E are congruent. So what that tells me is that angle E is congruent to angle G, and therefore angle G equals 90 degrees. All right, so that's the first thing here when it comes to this statement, right? If one angle is a right angle, how do I know that all of them are right angles? How do I know it's a rectangle? Well, here we go, the next one now. So now I know E and G. All right, well, what else do we know about parallelograms? Let me slide up just a little bit here so I'm not squeezing on you. The next thing I know about parallelograms is this. Consecutive. Let's call them consecutive sides. That means, consecutive sides. Consecutive angles that are going to be angles that are right next to each other. So consecutive angles in a parallelogram must sum to 180 degrees, or they have to be supplementary. So, consecutive angles in a parallelogram are supplementary. Which just simply means they must sum to 180 degrees. They have to sum to 180 degrees. Okay, well, what does this mean for us? Well, here's what it means. It means that angle E and angle F, must sum to 180 degrees. Remember why this is the case. It's a parallelogram. So, I have these two lines which, by definition, are parallel. Those lines have to be parallel. It's a parallelogram. Opposite sides are parallel. Well, those two parallel lines are cut by a transversal. There's my transversal. So what do I know about consecutive, or back when we were doing parallel lines cut by a transversal, we also called them same side interior angles. So whether you call them consecutive interior angles or same side interior angles, whatever, they have to sum to 180 degrees. They have to. So that's exactly what we've got here. I now know that angle E plus angle F have to sum to 180 degrees. They have to be supplementary. Well, that means if angle E, which I already know, angle E is 90 degrees, what does angle F have to be? Yeah, angle F has to be 90 degrees. It has to. Then all you got to do is go right back to this statement about parallelograms. Therefore, then H, because it is opposite angle F, because H is opposite angle F, it must also be 90 degrees. Opposite angles are congruent. So that's why that statement works. If you know that one angle is a right angle, then it must be a rectangle as long as it's a parallelogram. So let's go ahead and go to the next page. We'll try a couple of these together here. Let's take a look at this example problem right here. So here's what I want you to do. I want you to use, oh, sorry, hold up. I apologize. I'm making marks where I don't want to. I want you to use the given information to determine whether, very important, right here, I tell you this is a quadrilateral. It is a quadrilateral. So I want you to use the given information to determine whether the quadrilateral, this guy, is necessarily, does it have to be a rectangle based on the information I've given you. All right, we're going to do two of these. Let's see how they go. All right, so the first things I give you here are that EF and GF are congruent. Okay, well, there's EF, and there is, hold up, EF, GF, okay, FG, HE, I apologize. Look, this is going to be a typo. I'm sorry. That's why I'm getting... So that should be HG, this opposite side. Sorry, that is a typo right there. Scratch that out and put GH. That makes way more sense. So what we've got now, we have opposite sides that are congruent. EF, side EF, is congruent to side GH. Well, yeah, it's a parallelogram. I then tell you that FG, FG, and HE, right, opposite sides are congruent. Okay, so that's all stuff that we know. Great. None of that helps me show that this is a rectangle, right? Those are just properties of parallelograms. Opposite sides are congruent and parallel. but that doesn't necessarily mean it's a rectangle. So I have one more piece of information here. I tell you that FH is congruent to GE, and there it is. What this tells you right here, FH is congruent to GE. Well, those are my diagonals. What this means, the diagonals are congruent. And if you remember what we had in the table on the previous page of the notes, our second condition was if the diagonals are congruent, if the diagonals are equal, it has to be a rectangle. So yes, based on this information, it has to be a rectangle. All right, let's try the next one. So here's what I've given you. I have told you that the measure of FEG is 45 degrees. Sorry, I actually have, gosh, I apologize. I have another typo here. Scratch that out. This is going to be G-E-H. G-E-H. Okay, so essentially here's what this is. We have FEG, so F-E-G. FEG is 45. So right here, I know that that guy right there is 45 degrees, and I know that G-E-H, so this guy right here is 50 degrees. Now, based on that information, can I say for sure that this is a rectangle? Well, this one goes back to that first condition in the table on the previous page, which says if you have one right angle, then yes, the figure must be a rectangle. So all I need to know is, do these two angles sum to 90 degrees? Well, let's find out. I need angle EFEG plus GEH to equal 90 degrees. I have 45 plus 50, which gets me 50. Oh, ouch. 95 does not equal 90 degrees. 95 degrees does not equal 90 degrees, and so no, because this angle is not a right angle, it can't be a rectangle. So this one is not a rectangle. And I'm sorry, I should have written it up here. Yes, this one is a rectangle. So that's how these are going to go. Based on the conditions for proving that a figure is a rectangle, can we take the information given to show that it is a rectangle? What we'll do on the next page of the notes is we'll take a look at rhombuses, and I'll meet you there.